Number 3 then, from the 2013 Higher Maths paper 2, there it is. The cubic expression, show it's a factor, synthetic division and so on, and then use it again probably, because this is a part B, we'll see when we come to it, to find a stationary point. Well, first bit, show it's a factor and factorise it fully. So, synthetic division table, make sure you've got all the component parts, 3, 2, 1, 0, so it's 1, 3, 1, negative 5 for these 4 coefficients, and I've forgotten already, show that x minus 1 is a factor. If x minus 1 is a factor, then 1 would be the root. Remember, it serves a double purpose. It'll evaluate the expression at this number, or it'll do a division by x minus that. So I've got 1, multiply it up, add it down, multiply it up, add it down, multiply it up, and it adds down to 0. Now I was doing it as a division, so I'll have to use the word remainder. So I'll say this. The remainder equals 0, which means that x minus the 1 is a factor. There's the first bit, and all the work's been done here, of course, for the second part of this. Now factorise the expression, so x cubed plus 3x squared plus x minus 5, not equal to 0, it's not an equation, factorise the expression. Well, I've already got one factor, x minus 1, and the other factor is this quotient, because it divided in exactly, and that represents x squared plus 4x plus 5. X squared plus 4x plus 5, and then you would normally rush in, like I've done here, and say now factorise this, but you'd think immediately this is all positive, and a 5 and a 1 would make a 6, so this doesn't factorise any further. So shouldn't have rushed in as quickly as that with that part there. That is it fully factorised, because this quadratic won't factorise any further. Now we need to demonstrate that. So I could put the working at the side here. I could say b squared minus 4ac is going to be 4 squared minus 4 times 1 times 5, which is 4 squared is 16 minus 20, so that's a negative number. That means this doesn't factorise any further, but I need to make a comment to that effect. I'm never sure about that part, because you could just leave it there because you couldn't figure out how to factorise it, which would be the correct answer. I need to justify it. So I'd have to put a wee note here, maybe I'd put a wee note as like this. X squared plus 4x plus 5 does not factorise further. Following on from this part here, I think I would need to have that justification of it. Now part B, show that the curve with the equation y equals x to the 4 plus 4x cubed plus 2x squared minus 20x plus 3 has only one stationary point, and just get the x coordinate of it, not the y coordinate, but determine its nature. Well, let's differentiate it, so I'll have dy by dx will be multiplied by the power, take 1 off the power, multiply by the power is 12, take 1 off the power, multiply by the power, that's 4, and then it's just the coefficient, minus 20. Then I'll say this. So it's going to be stationary, or stationary point, when dy by dx equals 0. You need to have that down. In which case, 4x cubed plus 12x squared plus 4x minus 20 should equal 0. And you can see where that's leading, because there's a common factor of 4. The first thing I always do is take out common factors. Taking out the common factor of 4, I've got 4x cubed plus 3x squared plus just an x minus 5. No great tap it. And I've already factorised that. That just goes down to 4 times x minus 1 times x squared plus 4x plus 5 equals 0, which means that x equals 1 is the only solution. Maybe I should take a note of this, as x squared plus 4x plus 5 has no real roots. I know I did this in the first part. Had no real roots, and the working was in the first part. Maybe I'll just put a wee note down here again because I've rubbed it off. As b squared minus 4ac is 16 minus 20 is negative 4. Has no real roots, as that is less than 0, equals negative 4, which is less than 0. So there's that part. I'm just clearing this space here, not because I want rid of that, just because I need a bit more space just to finish it off. So it said, show it's only got one root, so we did that, but I'll just make the statement now. So, curve has only one stationary point, and that was at x equals 1, with that proof that was there before about the discriminant and so on. But you have to decide what its nature is on this little nature table here. There's only one thing happening, only happening at 1. So I just need something before and something after, and I'll be using this for dy by dx. I'd rather use this than that original one because I've got a factorisation. So I need something before it and something after it. Strictly speaking, I don't actually need these numbers. I know that comes to 0. If x is 1, putting it into this form is more useful than putting it into that form, because immediately that factor is 0, and anything times 0 is 0. Pick something slightly less than 1. Well, this part here. If I pick a number less than 1, this will be a negative, so I'll have 4, which is positive, times a negative. Now this didn't have any roots. If it doesn't have any roots, then that must mean it's always positive or always negative. If a quadratic doesn't have any roots, it means it doesn't cut the axis. And since that's a positive x squared, it must look like this. That means no matter what you put in for x, this part's always positive. So, back to this. Pick a number less than 1, like anything less than 1 in fact, that'll be negative. Of a positive times a positive, so that's going to be negative. Pick a number greater than 1, that'll turn positive. And these two are always positive, so the whole thing's positive. Which means the shape of the curve must be like this. I've got a minimum turning point. Curve is only one stationary point at x equals to 0, which is a minimum turning point.